applications of the slope and the distance formula. We have worked with the slope and distance formula many times before, but we're basically going to just review how we can use these different formulas when it comes to geometry. So just a review of the distance formula. This is the distance formula. Basically, you can use it to find the distance between 2 points. So if I wanted to find the distance between this point and this point, all I would do is plug that into my distance formula. So my x2 would be 3, and my y2 would be 5. My x1 would be -3, and my y1 would be -1. And so I'm just plugging all my constants in. And then that's what I'm solving for. That gives me 36 plus 36, which is 72. I can either go ahead and put this into the calculator and see what I get, which is 8.5, or I can simplify and it's 6. Square root is 6. 6 and the square root of 2, whichever your preference is, but basically that gives you the distance from point A to point B, okay? Any questions still about how to use the distance formula? Or what the distance formula even is? No? Okay. So we can use the distance formula to find perimeter. So basically to find the perimeter, we would find the distance from D to E, the distance from E to F, from F to G, and from D to G. So that would be 4 different formulas that we can work with. Just a reminder, if you're counting vertically up or horizontally left and right, then those are easy to count. So you can actually count the distance from D to E by going 1, 2, 3, 4, 5, 6, and they're going by 2 units. So D to E, the distance is actually 12. So basically 2, 4, 6, 8, 10, 12. And you can do that when you're going horizontally or vertically. It's with the diagonals that you kind of have to find the slope for. So we want to find the slope of EF. Basically, you plug in those 2 points, and when you solve it, you get that's the distance of EF, FG. Again, you plug in the 2 points F and G, and when you solve it, you get this. And G and D, when you solve it, you get 10. And so to find the perimeter, basically you're adding all those together. So 12 plus 2. And when you do that, that gives you approximately 35.4. And so that would be the perimeter of this figure that we see here. Remember that perimeter is just the outer region, so we're just counting for what is the entire distance of that outer region. But again, you're plugging in these different points into that distance formula. Okay, any questions? No, this is a lot of a review. The one that we haven't really worked with, but what we'll look at right now is now how do you calculate the area of a coordinate plane? So here you're told you have a right triangle with a hypotenuse BC, has these different vertices, and you can plot these different vertices. -2 and 5 is A. -4 and -1 is B. And then C is 1 and 4. And so when you put those things together, that creates the right triangle that you're looking for. And so what you can do with this information is the way, say it's telling me to find the area of this triangle. In order to find the area of the triangle, I need to know 1/2 the base times the height. That's the formula for area of a triangle. So my base will be A and C, and my height will be my A to B. B to C is my hypotenuse. That wouldn't be my height. My height is where my right angle would be located, which is opposite my hypotenuse. And so basically I can use the distance formula to solve for the length of this, A to B, my base, and the length of this, B to A, my height. And so when I put the points A, C into the distance formula, I get square root of 10, when I put AB in the distance formula, I get 2 square root of 10. And so that's what I'm plugging into my equation. Again, this represents my base and this represents my height. So 1/2 square root of 10 times 2 times the square root of 10. And then you plug that into your calculator and you'll see that that tells me that the area is equal to 10. So in this instance, the area is the intersection. And so that is equal to 10. So you want to solve for, whenever you're looking for area, you're going to solve for the lengths of the segments that you need. I mean, you don't need all the segments, so you don't have to solve for all the segments. In this instance, you only need base times height. And once you solve for the distance of that, that's what you can plug into your area equation. Okay, any questions about this? No? Okay. And then this we've seen actually in our previous unit, how do you determine if a point lies on a circle? We learned that you can determine if a point lies on the circle if whatever point you're looking for, this is supposed to say this square root of 12, if whatever point you are looking for has the same radius, or the distance of that point to the origin is the same as the radius of your circle. And so the radius of your circle here is 4. And so that means what you want is for the distance from your origin to the point that you're looking for to also be 4. Because if your radius is 4, then the distance from the origin to any point on the circle has to be 4 as well. And so for this instance, I'll go ahead and do it with you. My 0, 0 will be my x1 and my y1. And this will be my x2 and my y2. So 2 square root of 12, 0, 0. That gives me square root of 12 times 2. This cancels it out. The square root cancels that square root out, or the power of 2 cancels that square root out. So it's now 4 plus 16, which is, oh, no. It is now 4 plus 12, which is 16. And so your answer is 4. So because my distance matched my radius, that means that that point is in fact it lies on my circle. Okay, and that would be approximately right here. That would be 2 and the square root of 12. But we looked at this in our last unit, so nothing new. Any questions? No? So now we're going to look at slope of the line. We use the slope of the line to determine if we have right angles. We looked at this in Unit 7 briefly. But basically, here we have used the slope to verify a right angle. So we're trying to prove that this is a right angle. Well, if that thing is going to be a right angle, then my two lines, my perpendicular lines that form that slope, have to have negative reciprocals. So my two lines which create that right angle have to have negative reciprocal slopes. And if they have negative reciprocal slopes, that means they are perpendicular, which means that they intersect at a right angle. And so in this one, we're going to test DE and EF as having a right angle. And so I'll go ahead and put in my slope. So I'm going to find my slope of DE and then my slope of EF. So 6, 6, and 0. This one's also, I'll do this one, which is -4 and 6, which when simplified is -2 and 3. This one down here is again 6, 6. And my F is -6, -2. Simplify that. That is 12 and 8, which is 3 and 2. And so what I want to do is I want to identify if these two slopes are negative reciprocals of each other. because if they are, well then they form a right angle where they intersect. So wherever they would intersect, those two line segments, if two lines are perpendicular, they form a right angle, and so those two would form that right angle right there. And what we can identify are these two are in fact negative reciprocals of each other. So that means that this angle is in fact a right angle. Okay, any questions? No? Okay. And then another review, we were able to use the distance formula. Yes, do you have a question? Maybe it was an accident. Yeah. Okay. So we were able to use the distance formula and the slope formula to prove or to identify different figures. This is what we did in, I want to say it was Unit 7 as well. And so because of that, we used the distance formula and the slope formula to prove that side lengths were congruent or that we had right angles, so on and so forth. Give me 1 second, guys. Okay, so we did go ahead and do this before, but just a brief reminder. This one says determine the most specific name for this quadrilateral. So basically, we're trying to determine what type of quadrilateral we have here. And so what I'm able to do here is I'm able to actually determine if these sides, if these opposite sides are parallel, then they are quadrilateral because, sorry, I'm going to try to prove if this is a parallelogram. And the way that I'm going to do that is I need to prove that the quadrilateral that has opposite sides parallel to each other and opposite sides are congruent. So I'm trying to identify if these two opposite sides are parallel to each other. So basically the slopes would be the same. So basically I'm going to look at K and L and J and M. And for those two to be parallel to each other, they have to have the same slopes. So I have KL and J and M. 5, 0, 1, 3 equals 4 and 3. And so I want those two to be the same because if they are the same, then they are in fact parallel to each other. And so that gives me negative 4 and, oh, this is a negative 3 again. Negative 4 and 3. And so what you see is those two are in fact parallel. I'll rewrite this. It was a negative. And so because those two are parallel, that tells me that those two line segments are parallel. And so now I want to work with these line segments. Are now JK and ML parallel to each other? And so I would do the same thing. Trying to do this as fast as possible because I'm sure this is a lot of a review. 5, 0. Where am I? No, okay. One. This will equal to 1, and this will equal to 1. And because those slopes are equal to each other, what I meant to do? Because those slopes are equal to each other, why did I do that? That will tell me that this is a parallelogram, that this quadrilateral is a parallelogram, and if you're asking why, would be because a criteria for being a parallelogram where then my opposite sides will be parallel. Okay. Lastly, we have one that looks like this. This one says determine the most specific name for this quadrilateral. For this one, I'm going to prove it's also a parallelogram. But what I need to determine is whether my sides are congruent or not, or if my opposite sides are congruent. And so the way that I would do that is use the distance formula. So I want to prove that these two sides are congruent and these two sides are congruent. And these two sides are congruent and these two sides are congruent. So if those opposite sides are congruent, that satisfies the next criteria for it to be a parallelogram. And so I can, when I plug that in, I'll see that this is, and I'm plugging this into my distance formula. So I guess I can show you. That's 16, 16, which is 32. And so whenever you test all of them, you'll see that this is also 32. This is 32. And then when you test the other side, the KL side, you do the same thing. You plug those points in the distance formula, and you'll see that those are equal to 25. And so because both of the opposite sides are parallel, and because both of the opposite sides are congruent, that satisfies this being a parallelogram, so you can say that that's a parallelogram. If for some reason you had a square, what you want to do is you want to identify a square or rectangle. What you want to do is use your slope formula to identify if you have right triangles or right angles, and we just went over that. Okay, any questions? That's just a review. A lot of it was just a review. Okay. I will go ahead and post this actual slide with my handwriting on it so you can see it as on your own. But if there's no other questions, you guys may log off, and I will see you guys on Monday. Bye, guys.